Hi, I'm Larissa Schroeder from the University of Hartford, and I want to talk about our recent project to flip Calculus 1 as a means of improving student engagement. One of the things we noticed when we were talking about our calc program in the last year or so, 2 years or so, was that a lot of times when we were lecturing, we had students that were just kind of staring back at us in space as we were talking at them. And many of us in the department were kind of disappointed and discouraged by this. So we wanted to figure out a way to get students more actively involved in classes. So just to give you some background here, we have approximately between 230 and 250 students enrolled in Calc 1 every fall. This fall was very typical with 240 students enrolled in the fall. Spring semester, we usually have about half as many students. Slightly different population. Usually our weaker students take Calc 1 in the spring. Predominantly, we have engineering majors. We have a handful of math majors, a handful of math ed, a lot of chemistry and biology as well. We use Stewart Calculus Concepts and Context as our textbook. As a department, we use WebWork for homework. We use TI-89 graphing calculators, which are required. There are 6 of us in the department who have classroom sets of iPads, and we use those in our instruction. Some other instructors use Maple as well as Clickers. So the major pilot project occurred in the fall of 12, and we had a smaller extension project in the spring of 13. We really started the project in January of 2012 with department-wide discussions about how we might go about flipping calculus. And then this summer, and when I refer to we, I'm referring to 6 of us who are the primary component of this project. We created videos and course materials to be used in our flipping project. So fall 12 was our major pilot study. We had 10 sections of calculus, all taught by faculty members. 5 sections were flipped and 5 sections were not flipped. We collected a variety of data from both flipped and non-flipped sections. The calculus concept inventory we administered in the first day or 2 of classes and then in the last day or 2 of classes. We administered, we created common exam questions, just one question on each of the mid-semester exams during the year. And all students had to complete those questions, and we collected that data. We also traditionally had a common final exam, and this year we decided that we were going to grade it as a group, so there's consistency among grading, so we collected the final exam scores. We also conducted a survey with our students, as well as a small focus group. In spring 2013, the people who were teaching Calc 1 all had been what we called the flippers in the fall, and none of us wanted to go back to lecturing, so we flipped all 5 sections there. We didn't collect any of the pre and post data. We didn't collect any of the common exam data. We just did some focus groups and a mid-semester survey about 2/3 the way through. So to give you a sense of what my typical class might look like, we have a collection of videos that correspond with the content we cover in our course. As I said, they're all department produced. They're between 10 and 15 minutes long. And before classes, students are required to, or suggested, that they watch the video. They are encouraged to take notes, but they don't have to take notes. Then when they walk into class, they have an entrance quiz. And this is just a typical example of one of my entrance quizzes. The intention of the entrance quiz is to do 2 things. It gives me a very quick measure of how my students are doing. My class sizes are approximately 24 to 25. So I can very quickly look as they're working on things to get a sense of who has an idea of what's going on and who doesn't. I can also collect them and look at them very quickly before we start class. Oftentimes, I try to use that question as a way to launch into the class, where we start with some sort of discussion question with the class as a whole. I don't send them off to working on problems in small groups until usually we've had some sort of a whole group discussion. This is one of the classrooms I teach in. You notice I have round tables with 4 chairs at each table. So I have enough seating for 32 students, but we try to keep our class sizes around 25. If you notice in the background there's a whiteboard projector. In this particular room, in one of our other classrooms that we've designed for these more interactive classes, we have 3 Apple TVs connected to 3 projectors with an in-room network, so we can project student work from iPads that we are using up onto those boards. This is one of my favorite pictures of my students working, because the 3 gentlemen you see up front are projecting their work from their iPad up to the board, and they're actually talking about it. They're working independently as their group, but it's kind of in a public space. And it's not uncommon for another group to see what somebody else has displayed and me to hear either, ooh, or have another group get up and say, I don't get what you're doing over here. So it's a very nice dynamic. Let me go back. So one of the things that I noticed as we were doing this flipping project is there's more time in class to do some, what I'm calling IBL Light. It's not inquiry-based, but more activities that help students kind of dig into the content and procedures a little bit more deeply. And so I have a couple of examples of things that I've cooked up. One of them is this guessing derivatives lab. So we give them a collection of functions, f of x, and we ask them to graph here the function itself along with a difference quotient with two different values of h. And this might be h of 0.1 and 0.01. And then we ask them to continue this process with smaller values of h until the pair looks like it's gone down to a line. And the idea here is they're telling them this is an approximation of what the graph of the derivative looks like. What kind of conclusions can you make? If I have a quadratic, what does it look like? What's the form of the derivative? Is it linear? Is it cubic? Is it quadratic? Et cetera. And then we also use the TI-89, and we have them then use the limit function on the 89 to find the equation of the derivative without going through the whole process of actually calculating it by hand. That's something else later. The long-term goal of it is I want them to be able to answer some sort of synthesis question. So what can they make, what conclusions can they draw about the pattern for the derivative of x to the n? What's the relationship between the derivative of sine and cosine? Just trying to get them to do something a little bit more, less typical, I guess. This activity came out of the fact that I had a half an hour of class that I was going to have extra time for, and we were going to be going into looking at chain rule in the following class. So I wanted to think about what happens if I take the derivative of cosine of 2x. So I had them graph cosine and its derivative, again using the calculator, in this case the iPads, without actually calculating the derivative. But let's graph the function and its derivative. What happens when I compare the amplitude and the period of cosine of 2x to the derivative of cosine of 2x? Well, we know the derivative of cosine of 2x, you're going to have an amplitude change due to that coefficient inside the argument. Well, had them experiment with some values of a that were 3 or 4 values of a that are greater than 1, and 3 or 4 that were between 0 and 1. What kind of conclusions could you draw? And then we'd have the class talk about these things, what things they noticed. So then the next day, when we talked about chain rule, we kind of would be able to go back and say, hey, look what was happening, what we were seeing when we looked at the derivative of the graph of the derivative of cosine of 2x. Here's how it's linked together. And again, another one for fundamental theorem of calculus, again, trying to get them the idea that try to see the connection between the graph of this function and the function g of x. One of the things I really like about this question is asking them at the end to sketch the graph of a function so it has a minimum at x equals 3. And since I'm not asking for a linear function, I'm just asking for any function, I sometimes get curves, I sometimes get lines. But again, it gives us an opportunity to throw 2 or 3 different examples up on the boards and talk about what's common between them, what's different between them. So remember, our goal here was to get students to be more engaged in class. And so in the spring, we sent out a survey to our students asking them to approximate how much time do they think they spent in class talking about mathematics in small groups or with the whole class or with me individually. And if I add this correctly, we have 71% of our students think they spend over 50% of their time in class discussing mathematics. Well, in my mind, that's pretty good. That's a lot more time that they're spending doing mathematics as opposed to me talking about it. We also asked them how much time they estimate they spend watching videos. And the one on the right is spring, the one on the fall is the one on the left is fall. So we have about 55% of our students who spend an hour to 2 hours watching videos, versus about 45% of our students in the spring spend an hour to 2 hours watching videos. So they're probably doing about an hour extra work a week, because we still are requiring to do web work and homework. So there's no changes there in that part of what we were asking students to do. It's just we're asking them to try to engage with the calculus before they come into class. One thing that's disturbing to me personally when I look at this graph is I look at my spring students and I say I've got 47% of my students are spending less than an hour looking at these videos, which in my mind is they're either not watching them, that's the blue group, or they're just watching them straight through and they're not taking time to think about what's going on. They're not taking advantage of what our department is starting to call the Dora the Explorer moments. When I and some of my other colleagues in our videos say, pause the video now, try this problem on your own, take a look at our discussion about it. They actually like when you tell them to do that, but. So one last thing is talking about our results from fall of 12. Since in fall of 12, the survey we did was less extensive, but we did more data collection, data analysis. So we started out with 146 participants, we ended up with 115. That's probably a pretty typical attrition rate for us. We do not have a very strong population of students. They're generally For those of you who have SAT scores, we're looking at averages between 550 and about 550 for our calc students. So what did students think about our videos? They removed the fear of the unknown. They liked the fact there's a preview of what was coming into class. And Angie was talking about marketing, and that was really what we were trying to tell them, that you're not learning all about calculus when you watch this 10 or 15-minute video, but this is a preview of what we're going to dig into in class. They like to see what they were learning ahead of time. They really like the fact they can pause and rewind, they can pause and write and rewind. You can't do that in a lecture. It's gone. And they can refer to it, quote unquote, in times of need. Then again, it's not all sweetness and light. We have the videos were awful. Math is hard enough with the professor explaining, you ready to give feedback. How can a student learn calculus completely on their own? Well, what do they think of the structure of the class? Again, in general, they like the hands-on idea. They like the fact that they were working together and doing problems with classmates. They like the fact they said hands-on instead of lecture, how it should be taught, love the flipping method, etc. Fantastic class, etc. So we either had I love it or I hate it. There was kind of no middle ground. In all honesty, there was no middle ground at all. And then there's the, why don't the teachers just show us how to do the problems instead of putting us in groups and having us figure them out ourselves? I hate group work, lecture is way better. What's next for us? So the University of Hartford was awarded an NSF2's grant recently to fund the next stages of our research of this project. By the end of the summer, we're hoping to have a website up. We have a website, it's just not working at this point, that will be populated with our new videos as well as some of the classwork problems we are working on. This summer, we're currently in the middle of redoing all of our videos. We were all very proud of ourselves with our videos last summer and thought we were in great shape, and then we watched them repeatedly over the semester and kind of found where we had flaws. We've been meeting about these things, and it's really produced some very interesting discussions about teaching and learning as we try to revise our videos. We're really trying to improve our problem sets and augment our discussion questions, our entrance quizzes, try to make them align much better. In the fall, this coming fall, we're going to flip approximately half the sections. And more importantly, we're going to conduct a quasi-experimental design study. Me and one other full-time faculty members are teaching 2 sections of Calc 1. Half is going to be flipped and half is not, or one section is flipped, one section is non-flipped. So we have some comparisons with one instructor rather than in the fall of last year, we had 4 instructors flipping, 3 instructors not flipping. So we really had some variability there in teaching. So at least this will provide us with some sort of consistency among the 2 of us. My own personal goal is to include more inquiry-oriented activities and assignments. That's what I see. There's a great opportunity to do that in this particular class. I'm very open to it, and that's where that's my personal goal for what I'm doing. And that's all at the speed of light. Sorry.
Hello. Did you consider using instructional videos that someone else created, or the things that are online, the Khan Academy?
So some of our faculty members went and were looking at some of the videos, like for Khan Academy, and I think they found, in their brief sample of things, they found things that were disturbing to them enough that were not right, that they did not want to go that. We did not want to go that route. So we really felt that we wanted to do our own because we could target it in the way that was good for our students, but also they were leery about some of the mathematics that they had seen.
Just wondering regarding viewing the video.
Yes.
It's mandatory?
Yes.
So there was a hook. As part of the grade?
So we use Blackboard as our course management system.
Yes.
That has a very cumbersome way of checking whether or not students have actually watched videos without going and looking at each video individually. So I wasn't able to grade them as part of it. But the idea behind the entrance quiz was it was a daily occurrence, but it was a low stakes quiz. It counted as 1 quiz by the end of the semester, all of them all added up together. So it was some sort of a hook there to get them to do it. And I very quickly could tell who was not watching videos, because they would look at a problem and be like, what's in here? And it was pretty much pulled right off the video.
Here at UT, we've been doing a pretty massive project of flipping our calculus classes, and we're talking thousands of students.
Yes.
And it's in sections of 120.
Yeah.
And our biggest problem is getting students to buy in. That there's a large fraction of students that just rake us over the coals at the end of the semester in their student evaluations. And the pattern we seem to be seeing is that the more you talk about, here is this great system and isn't it wonderful, the more negative comments you're going to get. That the instructors who have done the best have been the ones who never mentioned the word flipping. And just go in there and say, hey, this is the way we're going to run our course, let's get started.
Certainly, that's a lot of what we did. So how I kind of did two things as far as marketing it. I was telling them how I believe that it's very important that you learn mathematics by doing mathematics. And having me talk about mathematics wasn't going to solve the problem. And then, as being a former athlete, I make the analogy of, so how do you get better at swimming? You don't sit there and watch somebody swim, you actually go and do it yourself. The other thing I tried to emphasize with my students is that when you walk into a history and English class usually don't do much on the first day, right? Because you need to go read something before you start having a discussion. So I was trying to get them to buy into the fact that this is some sort of preview of what you have to do in class. It's like what you do for English. I'm not sure they bought it.
Yeah. And I also wanted to echo what you said about the homegrown videos, that we used a bunch, for this last semester, for second semester calculus, we used a bunch of materials from the web, like MIT OpenCourseWare and various, Patrick JMT, and the students really didn't like it. And now we basically scrubbed all of those. All the videos are homemade.
Yeah, and we just felt that it was also important because at some point, there's 4 of us making videos, so at some point, all of my students had me on a video, lucky them, but they also could say, oh, look, Dr. Williams substituted for you when you were out at a conference, and I recognized him because he's the guy in those videos. And so it was nice to have that connection there.
Yeah, I was wondering about in your experimental design for next
Yes.
iteration, are you going to keep track of if our professors who are not using the flipped classroom model, are they having students do something extra 1 to 2 hours per week?
No,
that
we
is
haven't.
that is not watching videos. So I wonder that could be a criticism that.
Right, that's definitely a flaw.
so-
One of the things, we did not have them do something extra 1 to 2 hours per week.
Yeah.
Now, saying that, I don't know that any of the faculty didn't give them other assignments to do outside of class. One of the disadvantages I can see going forward in the fall is that we are unable to put 10 faculty members teaching the 10 sections, and so 6 sections will be taught by 4 faculty members, but the remaining 4 sections will be taught by adjuncts, and they will not be flipped. So, yeah. Okay. Thank you.